Today's lesson is again about visualization, but with the use of Seaborn as a library. Seaborn is a package that is already implemented in Python. It's based in the backend. If we are talking, it's based on a statistic and some analytics, and then the main point is the visualization of the data. Like we talked before about Matplotlib, the same way is Seaborn. Maybe when it comes to some density and some distribution functions visualization, then I would suggest to use Seaborn as a library. So mainly is based on analytics of or visualization of the statistics that we can make from the data. Now again, we're going to use the file detection. You know that this data set is containing three axes of x, y, and z values, one characteristics from the sensor data. We have four different unique sensors, as we know: the chest, the belt, ankle left, and ankle left, and ankle right, and then the anomaly containing zeros and ones. What is base characteristic to this dataset is that it's unbalanced, so we have more zeros appearing in the anomaly detection than ones. First of all, we need to import the Seaborn library as SNS. SNS is a shortcut. The import word means that we are adding the library into our, let's say, local environment. When we're talking about environment, the Colab as Jupyter notebook, it's having local environment and it's temporal. So when the data is when the local time you have in the runtime interrupt, when it's interrupted, then the environment is also killed, and in the next process, when you have another running of the program, you need again to import, not this way, but to pip install the libraries if needed. Some of the libraries that are not as default for the environment of Colab. But if you're using, let's say, a local Jupyter notebook, or you're using PyCharm, then you need to make your own environment where you will going to add all the libraries that you need. Mainly they are added with the pip install and the name of the given library. Now, because in Colab, this is a default, it's already implemented library, then we don't need to make pip install. If we make it, then we will get our requirements already satisfied as answer. That means that we have the Matplotlib, Seaborn, as you can see, Pandas, SciPy, NumPy, and etc. etc. Let's start with the visualization. As basic visualization, we have the histogram. So when we call histogram in Seaborn, we have a density plot or dist plot, and we are adding the values from, for example, x column. Now, here is the histogram. What's important here, as you can see, we have one function. What's the function appearing? It's the kernel density function. We can, for example, say here kernel density estimation by default is true. We're gonna make it false. So when it's false, as you can see, the kernel it's not applied. So one more thing is, if you want to appear just the kernel density and histogram to be false, so we're having histogram equal to false. Here it is. Now it's just the density function. If you want to name rock, we can make it true. What's the rock? Here is how the data is, let's say, divided, or how the data is initialized. We have, as you can see here on 6, just one instance, one gap, close to 12, and data till 18, I think. Now, what's the main point of the kernel density? The kernel density estimation is function that is making some smoothing to the peaks of the histogram, and this function right here is the best, let's say, the best visualization for our probability density, uh, for the probability distribution of the given x, of the given x color. Now, if you want to change a color, then you can make color equal to green, and we will have green histogram appearing. The next one is a line plot. As you know, the line plot is showing lines through the x values and epsilon 1. Let's take a look. As x values, I'm going to add x column, as epsilon column from our dataset. As you can see now, x and epsilon columns are given as labels for the axes, but if you have matplotlib, for example, then you need to add them. You need to add them manually. In this way, why the data is not having a flat line or some dynamic monotonic line is because this data, as you can see, it's going uh, uh, it's not a random, but it's some distribution that's on point based. It's not like a time series. The line plot is best used in a given time series where the data has some type of time dependency, and you can see how, for example, we are using it, for example, let's say COVID cases through the months, and you will see some peaks there, some minimum, maximums. We'll take a look at different advanced data set. Now, this is just an example for anomaly detection. The next is if we want to make it this plot with one more dimension, so we can add hue or a color. So I'm going to use the sensor column as a column that will select to be, as you can see here, to be the third dimension. Now I'm going to import the matplotlib, the pie plot especially, and take the figure and call the fig size. Now the fig size is a set of two uh, values. Let's say the values are first the length and the height of the plot. So I'm going to go with 10 10 square. If we take a look now, we have bigger plot where we have all the values. As you can see, the data is going like on edges, because x and epsilon are having peaks at a given time. Maybe we can add just for one value so you can see, or we can tell when df of sensor is having chest as a value, then get the x values. Like this. I have one bracket on here, and the same for epsilon. Here it is. As you can see now, this is better. Maybe we can make it with belt that is having smaller amount of rows, so you can see better the line. So as you can see, this is by instance. So first row, second row, third row, etc. The data is going on edges. Because of that, this is not some flat function. But as you can see here, the data is going monotonally, it's decreasing, and the values of x are getting bigger and the values of epsilon are getting smaller through the time. Here we have one peak that from minimum it goes up to maximum. In this peak, the anomaly detection is made. Okay, I can make here edit hue on PF when we have, let's say, anomaly. So now we can take a look of zeros and ones. Here you can take a look where the values are zeros in the blue, and the orange one shows, as you can see, this is a large change. So it's big change, it's a big step, and it's detected as anomaly. Here the values are smaller and are having closer peaks one to another. Okay, that's for the line chart. Now let's take a look of a scatter plot. How we make a scatter plot? Just calling scatter, and here also plot. It's a full name. And now the x values and epsilon values. Calling for now here the values are not having a big correlation, but let's take a look of x and z. Now if you want to take a look of x and sensor, here there are. So now in matplotlib we cannot make from a column that is having some category data. We can't make a scatter plot, otherwise different plots. But now with calling Seaborn in the backend, the Seaborn is making some labels for each of these values, and it's representing as value on epsilon axis. Here you can add a hue that will be uh, the color that we're gonna take. We're gonna take anomaly, for example. And now, as you can see, here is the anomaly appearing. This is a linear because we have how many of the instances and on which number are from chest, belt, ankle, and ankle, right? As you can see now, the data is fully in some distribution. Let's say it's not random, it's like normal coming up, because from 6 till 18 all we have a range of numbers appearing. It's not a centralized, it's not one center with a given bias appearing. We can make here also a scatter plot for x values and epsilon values. No, let's say z values, and have a hue on the anomaly. Now, here, as you can see, the data is in two clusters. The ones appearing the instances with anomaly are mainly between 7 and 9 on X, and for zeta values from 12 till 10. Here from 14 till 17, and in Z from 13 till 15. Now, why we need this? From this graph, I can know that with the decision trees, this problem will be solved. So if we make a classification model, so is the patient having anomaly or not? Is the sensor giving us some anomaly? Then I can use decision trees because we have clusters appearing right here, and the decision will be we have a good entropy appearing, let's say. For box plots, now when we talk about entropy and how the data is derived, how the data goes through the data set, let's take a look of the box plots. I'm going to take first the x values. As you can see, we had in Matplotlib and in Pandas a vertical box plot, but now we're having a horizontal one. In Seaborn, it's not implemented to have more than one box plot appearing on a given plot. So if you want to make some parallel box plots, I suggest using box plot that is available in Pandas, and here you will add your column name that you want to use. We have now x, y, z, and here there are parallel. In the box plot appearing right here, you can detect 6, that is the minimum, 90, that's the maximum value, the median is appearing right here. It's, if we take a look, median, it's 13.5, which is right here. From this function, we can take a look and tell how the distribution goes. Now, as we can see, it's a negative skewed function because the median is going closer to the third quartile. If we take a look of the Z now, here you can take a look. It's mainly a normal distribution. The median is at the half of the box plot. The next one that we are having is the swarm plot. From the Seaborn, we have swarm plot, and for example, for one data, for X, let's take a look. It takes some minutes or seconds, I think, for generating it. What's the swarm plot? Let's talk about that firstly. So the swarm plot, it's mainly to see how the instances go through the time. So how the instances go by row, instance by instance. So how many of the instances have 6, how many 7, how many 8, how many 10 value, etc., etc. And you will see the distribution of X. Mainly, it's the same as the box plot. So you have minimum and the maximum value, and then a median here appearing. But also, here it is. Also, you have points for each instance that's disappearing. So for 6, you can have a look and say, okay, I have only one value of minimum, and then maybe I can delete it and have 7 as a minimum, or 6 point something. Then you see that here you have some gap of the data. It's like a channel. It's it just it's too it's so it's small an amount of instances that are coming. And if at some point, if you have big data, then you may delete this one because it may be making noise to your data. But firstly, you need to analyze. That is part of the data analytics, and the visualization is part of understanding your data and then analyzed. So from this, we can make a conclusion that here this data is having some gaps. The minimum is just one instance appearing as 6, and all other values here are well distributed. For the bar plot, mainly use bar plot are for counting something, to count some instances. Do they have some distribution? But now I'm showing just for you the bar plot of X with Seaborn bar plot are representing an estimate of central tendency of the numeric values that we have here given as an array or a series. uh, we have height of each rectangle, and this provides some indication of uncertainty around that estimating, some using error at the bars. So the bar plot can include zero in the quantitative axis range, and they are a good choice when we have some zeros. Here, as you can see, we have zeros that are having some meanings as we have in our data. For example, let's take a look. Do uh, we have values starting from 0 point something. If we have but as minimum we have 6. So these values here are are made with some normalization to them. The next one, we're gonna talk about a count plot. It's same a bar plot, but it's having count as main characteristic. I made here a mistake now. Oh, okay. Now, as you can see, for the sensors, if I make a count plot, it's making the same as sensor value counts. And now if we take a look, ankle left, it's having under 1,600 values, then belt with 640, then chest, and at the end ankle right. So here are the counts of each rows appearing with chest, belt, ankle left, ankle right. It's used this function in the back for applying the visualization form. As you can see, again, different from the matplot is that the sensor and count are already auto-generated as titles, labels for X and Y axes, and chest, belt, and ankle left and ankle right are taking X sticks for the X axis. As endpoint, at the beginning, we talked about kernel density. Now, kernel density, here we applied as a function for a given X. Now we're going to apply kernel density for having dependency between two different columns for X and Y column. If we take a look of the kernel density plot, again, it's calculating kernel function. It's making a visualization that will be like circles. What it means is that here the circles, how the circles are closer one to another, are more frequent, the data is more close, it's having a bias, it's centralized. How the circles are, let's say, are making distance between them, the data is having gaps. As you can see here, the data is like in an outlier appearing. So this data should be, I think, erased if we make better analytics of this data. The peaks are appearing here and here. The circles here are, let's say, more closer, more frequent, and having a big radius. As final, I'm going to talk about a pair plot. Pair plot, it's calling on the full data set. Now, in the pair plot, we are having metrics of all the plots. In the diagonal, we have the histogram for anomaly with anomaly, z with z, epsilon and x for each of the distribution of x, epsilon, z, and anomaly we're having. As you can see, we don't have the sensor because it's a categorical data. Here, we don't use categorical data. Pair plot is only applying plots, scatter plots on numeric data. Now, here we have for x with epsilon, x with z, then anomaly with x, and again x for z and epsilon, and for the anomaly. As you can see from this graph, I can tell that I have dependency between x and z, that is some log appearing here, some log function, epsilon and z, again, some uh, minus log, I think that is on epsilon mirrored up, as if you take a look of z on x and z on epsilon. And at the end, for x and epsilon, I can tell that here the data is having more fraud, is more noisy, and is having some monotonic decreasing appearing. Also, for the anomaly, as we said, unbalanced data set from the pair plot, we can obtain the distribution appearing here that we have. So I will say the z is having some normal distribution, the epsilon is having mainly exponential distribution, and x, it's it's not so it's not so clear what the distribution is to be declared. That's all for the basics of Seaborn. Go to the next video to take a look of the new library that we're gonna talk